we ended up at page 11, okay, where we visually inspected and we're able to fill out a lot of the examples. Okay, so now we're going to take a look at, okay, where would we actually use a quadratic, or how can we put a little bit more into a real world situation, right? Because what's happened is scientists have observed things happening in nature, and they recognize that certain motions, certain behaviors, certain things could be represented by mathematical functions so that we could predict movement, speed, height, angles, impact zones, all kinds of things. So if those of you taking physics or planning to take physics, you're going to do a whole unit on like projectile motion. Okay, and so it's going to be like you're going to fire something out of a cannon, or a car is going to come over a jump at a certain velocity, right? It's going to fly through the air, and you're going to notice that it's going to go in the shape of a parabola. So that means that you can use a quadratic equation in order to determine the highest point that the car will reach, how far away from the jump it will land. Like, these are all things that people actually need to know. Like, a stunt coordinator would need to know these things, right? The camera guy would need to know like what angle to point the camera up to make sure he gets the car in the scene, because if he's at the wrong angle and they miss the whole thing, okay, producer director is going to be pretty mad. They got to know how much juice to put in the rockets in order to get that, you know, velocity, speed, and such. Okay, our example that we're going to go through today is not quite as exciting. It's about a frog who's sitting on a rock and he jumps into a pond. Okay, but we can still model the movement of something jumping, okay, by a quadratic. Okay, so a frog is sitting on a rock, jumps into a pond. The height, h in centimeters, of the frog above the surface of the water as a function of time, t. So first of all, just observe that we're not using x and y. So if they give you variables to describe something, you need to use those variables. Okay, you will, like when we, like at the end, right, we're going to be talking about domain and range. If you give me the domain and range in x and y, you'll lose marks because it doesn't mention x and y. Okay, it mentions t in seconds and it mentions h, right, in height. So you would need to use those variables when you're talking about domain and range. Okay, so first thing that we're going to do is we're going to graph the function on our graphing calculator. Okay, which means that just looking at it, I'm probably going to have to change my window settings so that I can see it. So go ahead and pull out your graphing calculator. You're going to practice here with me. Okay, and with these questions, even if you're doing something on your graphing calculator, you still need to make a sketch on the paper, right, to show what you're seeing on your graphing calculator. Okay, so just get in the habit. Even if you solve things with your graphing calculator, you still write down, right, the process. You show the substitution. You show the sketch, those kinds of things. Okay, so let's head over. Okay, so we have our function, negative 490. Okay, obviously your calculator, let's clear that out, is going to be taking x. Right? But so our t squared is still x in the calculator. Okay, x squared plus 150x plus 25. Okay, so if we just graphed it, okay, and actually, my calculator showed still what we did yesterday, right? And it kind of had that xy coordinate that was a little bit skewed. If you ever just need a reset, okay, if you do zoom 6, this Z standard, again, just gives you your negative 10 to positive 10, negative 10 to positive 10 for your X and your Y scales. So that's always a good place just to reset it and take a look at. And like, you can't even see anything. Okay, so let's actually think about this, because right now, okay, we're talking about time. Okay, does negative time make sense in this context? No. Okay, so right away you could change your window and you can say, okay, let's start at 0. Because we're not interested in negative time. Okay, and then when we graph it, okay, we see this little line. Because right now I'm saying that I'm looking at 10 seconds. Okay, is my poor little frog, is he like airborne for 10 seconds? Like that wasn't even 10, that was like 3, okay? So no, 10 seconds is way too long for a little frog to be jumping. Okay, so we could, what do you think? We could do 1, we could do like, if you're, this is a little bit of guess and check, right? Like you might say maybe 3 seconds, maybe 2 seconds, right? There's not, okay, maybe 1 second. Let's take a look. Sorry, graph. Okay, so we can at least see it. Okay, that's a start, but we can't see anything else. So we have to go back to our equation and notice that our y-intercept is up at 25. Okay, so we need to at least see our y-intercept. Okay, but let's take a look. Window. Oh, with our graph, okay, if we read the story, okay, the frog above the surface, okay, it jumps. Okay, we're interested, like if I'm reading through the questions, D, when does the frog hit the surface of the water? Okay, I'm not interested in, okay, like learning about the frog swimming around in the water. Okay, I'm kind of just interested in the water. Okay, so let's change our, okay, we can keep the minimum there for a second. Our maximum, we said we need to see at least 25, right? Okay, so we still can't see it because he starts at 25 and he's jumping up. So what do you think? What can we change to that? Like, should we, maybe 50? Okay, graph that. There we go. Okay. So you play around with it. So here's the thing. When you like do your sketch, okay, writing down what your window settings are helps you, like if you ever come back to your sketch and you're like, I have no idea how I got that graph or what my window settings were. So just write in what your window settings are. If I ask for your window settings, there's not like a correct answer that you have to hit, as long as in your window you can see all the critical information. Okay, so there are some incorrect window settings, right? If I can't see the maximum of my parabola, or I can't see like my intercept point, then I would say your window's not, you know, tall enough, your window's not wide enough. Okay, but if you make it like really all encompassing, and as long as you can see everything, technically that would be a correct window setting. Okay, so here's, okay, I'm gonna do my sketch. Okay, so I have this. So here's kind of what's going on. I'll put it down here a little bit. Okay. So what we're seeing is that we have this y-intercept, and then we kind of have this. Okay. And this is my h. Okay, this is my height. Okay, and this is my time in seconds. This is my height in centimeters. Okay. So what is the y-intercept? What's going on? How is it that I have a y-intercept kind of way up there at 25? Yeah. Yeah, why does it start 25 centimeters above the water? A frog's sitting on a rock. Okay, so yes, it's part of the formula, but we also want to interpret how did he start 25 centimeters above the water? Okay, he's sitting on the rock, which means the height of the rock is 25 centimeters, right? And that's where he's starting and then jumping from that. Okay, so what is the y-intercept? So, and the y-intercept, remember, is, okay, h at 0. So in function notation, we'd say h of 0, and that equals, okay, 25. So that means at the initial time, right? When time is equal to 0, so that the initial moment of starting, that would be the height. Okay, so the initial height, and what does it represent? The initial height of the frog, okay, was 25 centimeters. Okay, so to just recognize this is the height of the rock. Okay, so something like that. And just a note to myself, right, we are, instead of using X, we're changing that to T, and our Y, okay, that becomes our H. All right, what maximum height does the frog reach? And when does it reach that height? Okay, so this is with your calculator, right? So with your calculator, you are looking for the maximum. Yeah. You can write it. Okay, so that's a great question. Okay, you can write it in function notation. This is what I'm looking for. H at 0 equals 25. That is sufficient. Or, okay, you could give it to me as a coordinate pair. Okay, these are two different ways of saying the same thing. Okay, function notation or as a coordinate pair. The only thing that I don't want is H equals 25, like just an H, or like Y equals 25. Okay, it has to be H at 0, so that's function notation or as a coordinate pair. Yep. Because again, in this context, this just makes a little bit more sense, right? Because I'm thinking of a frog in real time. I'm not thinking of a frog, right? I'm superimposing the coordinate grid on top of it so I can make sense of the math. But when I'm thinking of the frog, I'm thinking of like at time, 2 seconds, or at time half a second, and what is the height? Okay, so I think more like this, right? At time equals 0, the height is 25. Right, so what is the maximum height? So you're going over to your calculator, right? And we're doing second trace to get to the calc features. We're doing maximum, so number 4. Okay, and again, it just wants you to be a little bit left bound. So sometimes you just have to find your cursor. Where's my cursor? My cursor is at, my cursor is like way, way to the left. I'm looking at my Y values and it was like negative. Okay. So you can bring it up, or I believe that you can just type in a number if you know that that's to the left. If you're not sure what's to the left, just use your arrow over until you get to the left. Come on. There. Now I'm for sure to the left, and then just nudge it over a little bit to the right so it can find that max. Okay, there we go. So the maximum is Y is equal to 36.5. Okay, at 0.2. So we're just going to round everything to the nearest 10th. Okay, I don't think it says, but we're going to round to the nearest 10th. Okay, so you could write in the coordinate for the max value, okay, which was at 0.2 and 36.5. However, okay, that's the math part, but it asked you a question. So make sure that you answer the question in words to give context and to use units as appropriate. Okay, so you've done the math part, but you need to say, okay, the max height is 36.5 centimeters. And then it says, when does it reach that height? Okay. I don't have room here. Okay, so I'm just gonna pretend my sentence was over here at 0.2 seconds. Okay, so notice how both of them have units. Okay, we've answered it in the sentence. Or you could say at time, 0.2 seconds. Okay, so here's an example. Again, so going back to like kind of what Kessler was asking, right? You can write it as an ordered pair if you want to, okay, in function notation. You could also write it at H at, okay, when it's 0.2 seconds, that's when we're at 36.5. Okay, so either the red or the black, you don't have to do both. Okay, if you like function notation, use function notation. If you're more comfortable with the coordinate pair, then use the coordinate pair. Okay, you don't have to see both, but you can, I'll write them just so that you can kind of see what we're doing there. All right, when does the frog hit the surface of the water? Okay, so visually, okay, froggy's hitting the surface of the water, okay, because the water is like my zero, right, is my x-axis. That's the height of the water. Okay, so how could I find out what is this when it hits the water? Like what would we call this in the coordinate in our thing? Yeah, Felix. Yeah, that's our x-intercept. Or as your calculator calls it, that's your zero. Okay, so that's what we're looking for. So this is our x-intercept. And that signifies when it hits the surface of the water. Okay, so when does that happen? So we go back to our calculators, okay, and we're looking to figure out the zero. Okay, so we go second trace, okay, and we say number 2, we ask for the 0. Okay, and again, we nudge over, let it know, whoop, I went a bit too far. Okay, enter, enter. Okay, and so it tells us at 0.4 seconds, looks like it's hitting the water. Okay, at y = 0. Okay, so we can do it with our calculator. Okay, and we get a 0 at 0.4. Okay, we could also, okay, we could also write, so for those of you who want to see it in function notation, right, so at 0.4, the height is 0. That's what we're going for. And then the frog hits the water at 0.4 seconds. Now, technically, okay, because your parabola keeps on going, right, underneath the y-axis, okay? So, I mean, technically, anything beyond that is like the frog is like now in the pond, okay? We're not interested in that, but that could be an extension kind of question, right? It might, like the question might say, after, so the frog jumps off the rock, and after 2 seconds, settles onto the bottom of the pond. How deep is the pond? Okay, it could ask something like that, in which case you would want to, right, go to 2 seconds and then see what the depth is. Okay, but for us, we're just looking at the surface of the pond. We're not interested in anything else. Now, like if we switched our window, okay, your parabola technically extends into this area. Okay, it technically has another 0. Okay, what would we call this when we like disregard one of the zeros? Yeah, extraneous. Yeah, so remember when we answered questions last year, and there were times when, like when we solved our quadratic or we solved our thing, and maybe there's like a plus or minus value, and we like crossed one off and we said, this is extraneous. When we were doing like trigonometry, right, and we were solving for, I think it was like one of the sides of the triangle or the hypotenuse, right, because when you do Pythagorean theorem, there's a squared, right? A squared plus B squared equals C squared. And so sometimes we had to solve for the square root. Now, technically, any answer for a square root, because it has an even integer, has plus or minus. And so we said, well, it doesn't make sense to have a negative side length. So we cross it out when we'd write extraneous. Okay, same thing is happening here, right? In this situation, we don't deal with negative time. And so even though mathematically there is a root there, it would be extraneous in the context of our question. Okay, but I did want to let you know, okay, that it does exist. Okay, so it's extraneous in the context. All right. How high is the frog 2.5 seconds after it jumps? Okay, so you can do this a couple ways, right? Because what it's asking for is the height of the frog at 2.5 seconds. What I want you to do, okay, and some of you, I think this is where some of you kind of, do we really have to do this? You need to show me the substitution. The substitution, because we have an equation here. Okay, so you're still going to use your calculator to give you the answer, but I want you to show me like what's going on in order to get it. Okay, so in this case, we're substituting in time is equal to 0.25 wherever time showed up in our formula. So in our formula, right, we had, so let me just write it down here so we have it. Okay, this was our formula. T squared plus 150 t plus 25. Okay, so I would want you to just show me the substitution. Oh, not 2.5, silly. 0.25. Okay, plus 150 plus 25. Okay, and then you're going to give me the answer. Now, we already have everything in our graphing calculator, so we could head over to the graphing calculator. Okay, and we could just go, actually, we don't even have to do, I don't want alpha. Okay, we're still on our graph. There we go. Okay, you could do trace, and you could say 0.25. Okay, and it would give you the value of when time is equal to 0.25. Okay, our y value or our height is 31 point, with rounding 31.9. Okay. And then we just write our sentence at 0.25 seconds. Okay. The frog is at 31.9 meters high. Okay, so I would just want to know where the answer came from. Okay, algebraically. So sometimes I get that we're solving it graphically, but you also need to, if it says determine, right, you just need to show algebraically, okay, where that came from. Okay, and then what are the domain and range in this situation? So they want you to keep it in the context of a real live living frog jumping off a rock and landing in some water. Okay, so your domain, okay, no longer is it x such that x belongs to real numbers, no restrictions. Okay, we do have some restrictions. So what is our range for this? Logan. Okay, does time stop in the context of this question? Okay, once he hits the water, we're not interested in him swimming under the water. Okay, so time technically stopped when he hit the water. Okay, so what you're going to do in this situation, okay, and remember we're using, even though I gave an example with x and y, okay, we're going to be using t and h because those are the variables that they gave us. And, okay, you always start with your low bound and then you go to your maximum. Okay, so we start with 0 and we say it can be greater than or equal to, okay, 0 and less than or equal to, what did we say was our intercept? When it hits the water, here we go, 0.4. Okay, in that context, it can still belong to real numbers, but it only exists between time 0 and 0.4. Okay, and guys, it needs to be in this order, minimum, maximum. Okay, last year, a few of you had the numbers right, but you switched it. Okay, I'm not marking that correct this year. You cannot flip it. It has to be in this order. We read it from left to right. Okay, so I never want to see 0.4, I'll show you what I mean. Okay, I will not accept this, even though technically, right, you flipped your signs, everything is mathematically correct. Okay, we do not accept this order. Okay, it has to be lowest to highest. Okay, so I'm just going to take this right out because I'm never going to see it from you guys. All right, and then our range. Okay, so what's our low point for the range? What's the lowest height that we hit? Yeah, 0. What's the highest point that we hit? Okay, we just look up to your question and see what our maximum height was. Okay, so you grab it off of that. So again, not the maximum window setting that you have, but the maximum height of the actual parabola. Okay, there's no units when we do, okay, when we do our signs. Okay, we don't put units in domain and range. Okay. I'm just making sure that I covered all the little things that I had written in my notes. Okay, so what we're going to do is I'm going to start. I'm going to introduce our, that's your quiz, our next topic. We're just going to kind of get it's a little bit of a review, and then we'll get into the meat of it on Monday. Okay, we will be coming back, right, and assigning this for homework. Okay, I'm just going to do a couple things. I might even have class time to get you guys started on your practice questions. Okay, yeah. Oh, no, you do. Yeah, sorry. It would go here. Okay, so. Yes. Yeah, you would still have T such that and H such that. Sorry, guys. Okay, because we do want to be accurate. We want to be complete. I just jumped right to the good stuff, and I kind of forgot that. Right? It happens. Thank you very much. Okay, I'm going to make one more change, guys, as I'm looking carefully at my notes. Guys, my function is technically H at T, not just H. Okay, it is. Okay, if this was like a Y, okay, and I'm writing it in function notation, it's not just H. H is a variable, but the function is H at T. Okay. And then that one would also be fixed up here. See, now that you've had to correct it, it will draw your attention to it when you're reviewing your notes. And then that way you'll be able to be like, oh yeah, not just H, but the function notation. Okay, so in function notation. Okay. So let's take a look at, okay, I'm going to write out a few things. So this one we can do as a little bit of a mental kind of pattern recognition. Okay, I'm going to write out. Okay, so we're good with what the squared means. Let me just make sure my numbers are correct. Okay, I'm going to do one more here. Okay. Okay. So last year, when we did this, right, we introduced the idea, or maybe you got this in grade 9, where we talked about FOIL, right? When you're expanding a binomial or something, like mathematically, we call it the binomial expansion, okay? But I don't tell people like binomial expand. I just say do FOIL, right? First. So don't forget, okay? We do the 2 firsts, and then we do the 2 outsides, the two insides, and then the two last ones. Okay, as we're doing this, okay, as we're looking at squares, the reason why we're focused on this is because don't forget, in vertex form, we've got this x, right, minus p all squared. So we need to be very comfortable when we're expanding from vertex form to get to standard form. Okay, and next week we're going to be learning how to like get the other way. Okay, so we have to make sure that we're good with our expanding. Okay, so a lot of you, if you did FOIL, right, you're going to be x squared plus x, and then 1 times 1. Okay, so what I'm hoping, is, especially when we're doing a squared, okay, that we start noticing things and that you start, maybe you guys are going to be able to like do some of that collecting in your head, so that you don't have to write out all 4 terms, that maybe as you're doing this, you can be like, you could go to x squared, and I know I have a 2x and a 2x, so that's 4x plus 4. Okay, are we there, or do we need to write everything out? Okay, so some of you might want to still write things out. I'm encouraging you to, okay, especially when they're squared. Now, if they're completely different and you just need to keep track, like that's fine. But when they're squared, we should start noticing a pattern. Okay, so I'm doing x squared, 3x plus 3x, 6x, 3 times 3, 9. Okay, here I'm going x squared, okay, plus 8x plus 16. Okay, here I can go right to x squared plus 10x, okay, plus 25. What are we noticing? What's the relationship between, okay, like what, how do I get from, okay, I don't, I'm going to write it under here for a sec. No, I guess I wrote it all the way to the side. Okay, like let's look at this. What's the relationship between this number and this number? Yeah.
Add it by itself.
Yes. Okay, so another way of saying that, right, is like we're doubling, right? Or if we go this way, okay, I'm just, okay, I'm going to actually write it as I'm dividing by 2. Okay, now if I go from this number to this number, what am I doing? Yeah, we're squaring. Yeah. Okay, so we're going to notice, just depends on which way I do if I did the arrow this way, right, doubling or halving, okay, and then this way would be squaring. Okay, you might see me, if I'm doing squaring and I don't want to write out the word, you might see me use the caret. Okay, this little guy, that's called a caret. Okay, caret 2 is another way to show squared. Because if I just write a 2, like a really small 2, to show that it's an exponent, like we're just not going to remember that that's an exponent. We might think we're multiplying by 2. Okay, so as you can see, okay, the pattern here is, okay, we end up doubling. So we multiply by 2, okay, and then we square. Okay, so what I'm going to do is I'm going to, okay, you'll see this for a reason in a second. I'm going to do the arrow this way, and I'm just going to keep us kind of focused on, I'm also, if I started with this, I could go back to this squared term, right, by taking half, okay, and then moving forward to this squared. So if you turn your page, okay, to page 12, okay, here's a little bit of a review, okay. So I want you to write these out. So the beginning part, okay, you're still going to be showing, right, that we're multiplying these out, okay. Now, your next step, you decide if you're going to write all 4 terms or if you can start doing some of this in your head. Okay, we're going to get to x squared plus 8x plus 16. Okay, this one, we have x minus 2. Okay, and we end up with x squared minus 4x plus 4. Okay, so fill in the next 2. And then I just want to make a few more observations. Yes. Just a sec. Okay, so this one. So, oops, let's write it out. So a couple things that we can notice here. All right, so we notice if this, okay, in our perfect square, if it's positive, okay, both of our terms in the trinomial or the quadratic. Okay, I'm going to probably use both of those words because I'm teaching trinomials to the tens. Trinomial just means it has 3 terms. Okay, for you guys, it's a quadratic because it is a degree 2, okay, polynomial or a degree 2 trinomial. Okay, so I might just use both terms for you guys. Okay, so we just want to observe that when this is positive, okay, that both of these are positive. Okay, when this one, we notice that when this one is negative, okay, the middle term is negative. However, always, that third term is always going to be positive because we're squaring it. Okay, so just kind of, again, we're just like looking for patterns so that when we take the next step, that we can still recognize those patterns. Okay, now for this part, okay, we did a little bit of a warm-up at the beginning of this unit where I gave you guys a review sheet and I was like, factor these things. And you guys are like, oh, it's been a while since we've had to factor, right? And we had a lot of options. We had greatest common factor, we had product sum, we had difference of squares, we had decomposition, we had grouping, okay, we had all the things, okay? What we're going to be looking at is we're going to be looking at product sum. Okay, we're going to be looking at product sum. But looking at the time, we're going to be looking at product sum on Monday. Okay, so what I want you to do is you do have, okay, the rest of these questions, okay, which will be, I think those ones are a little bit more of the practical kinds of questions. Okay, do those for homework and then we'll jump into completing the square on Monday.